time, and she has been working for around about 20 years at CERN and maybe 25 years in particle physics, and now she's retired from the University of Indiana. I think yesterday it was false. I said it was Idaho. It's Indiana. So sorry. Yeah, and so I hand over to you.
Okay. Thank you very much again. It's a pleasure to be here, but what have they been doing to you that everybody is so tired? What is this summer school about?
Okay, so input to process.
Yeah. So, is this, yeah. So, I'm going to talk about my experience as a physicist, a particle physicist. So I'll start with my personal story, and I want to talk about different experiences that I had, good and bad. And then I will ask ourselves, was that really personal? And put it in a more general political context of what is it to be a woman in science, to be a lesbian in science, to be a French-Canadian lesbian in science. I had all sorts of difficulties. So what did I do? So just briefly, I come from Quebec, so this is a view of Montreal. In '78, I went to Université du Québec à Montréal. I got a bachelor degree in physics. Then I taught physics in 2 colleges in Quebec, in Canada for about 6 years. Then one of the best things that I did for my career was to fall in love. I met this woman. She came from California, so I moved to California. And I enrolled I went back to school because I entered the US illegally and all that. From Canada was not so difficult, but to stay there, I needed to get a visa, and the easiest way was to go back to school. And in Quebec, we were not encouraged, French Canadians, you know, there is a problem with people were, it's an oppressed nation, and so we were not encouraged to go and study more and all that. But in California, everybody was going back to school, so why not? So people told me, oh, you should go back, and okay, I did it. I went to, and I did a master's degree in physics at San Francisco State University. And after that, I did a PhD in particle physics at UC Santa Cruz. Then I came back to Canada, back in the winter, but Ottawa, the capital of Canada, has a wonderful, it's a canal, and in winter you can skate on the canal, and I would go to work skating 5-6 kilometers to go to work. It only lasted 2 months, but anyway, it was wonderful. And then I moved to CERN, and I worked on various experiments there. In 1999, I became a senior research scientist with Indiana University. And in 2014, I again fell in love with a German this time. So I moved to Nürtingen, which is close to Stuttgart. And I retired from CERN. I left my job at CERN and wrote a popular science book. Unfortunately, for various reasons, I could not bring copies here, but I can give you my business card, and you can see a bit about the book. And since then, I've been spending most of my time giving public lectures on physics, on women and diversity in science, as well as on Mileva Marie-Schenstein. So I'll talk a bit more on this. And I'm now working on a film project. I'll say more about it. So that's my, my book, Who Cares About Particle Physics? So it talks about, it really starts from the basics for people who are just curious about particle physics. And it's written that in a way that anybody who is just curious should be able to follow what's happening. And I talk not only about the science, but also about diversity, about the importance, why do we do science, and what is the impact for society and things like that. And the special management style of those experiments, that's also special. So was I really different from the other girls? I was terribly curious. Here is a picture my father took on my first day going to school. And when I was in 5th or 6th grade, the teacher asked us, what do you want to do later on? And I said I wanted to teach chemistry at the university. And everybody was looking strange. Everybody wanted to be a nurse, a teacher, a flight attendant. So saying that I wanted to be a scientist and that I wanted to know what matter was made of, for some odd reason, that's something that, as far as I can remember, that's what I wanted to do. And so, Who helped me get there? Well, my mother was very supportive. She said she really wanted us to go to school. We were 5 kids in the family. She did not get to go to the university because she had too much fun in high school, laughing all the time. And my grandfather said, "You're just wasting your time." And she was sent to home economics, so to learn how to cook and clean and all those things, to be a good housewife. She was an excellent cook and all that, but no, she would have liked to study. She went back to school later on. But I also had 2 science teachers who were very encouraging. A chemistry teacher who took me seriously and gave me access to the labs. I could do some experiments after school, and that was a lot of fun. Who made it harder? Who and what made it harder? Well, my mother. Because my mother, she wanted me to go to university, but science was not what she had in mind for me. She thought, then she would say, "Oh yeah, but chemistry, you have so much eczema, so skin problem, and then, oh, you'll have too much problem with that." And then I would say, "Yeah, but I can wear gloves." And I would always try to counteract their arguments and all that. But my mother was just reflecting what was going on socially. Women are not going into science. So my peers also were surprised that I wanted to go to science. The teachers, many of the teachers, when I was going through university and all that, we were told, they would always talk about us and them. The women, us, and the men, us, most of the class, and the 1 or 2 women in the class. So they were always putting us against each other. So that was also difficult. And there were, of course, lots of sexism in society that made it that it's like I did not belong there. And this message I received it so often. Science was a lonely place for women in the 70s and the 90s when I was going through school. When in Quebec, the schools, the public schools are run by the Catholic nuns. So we were there, we always had, I guess that's so we always had a nun somewhere and all the girls with their uniform. So I was used to something like that. In high school, there were about 35 girls in the class and it was all girls. Then I moved to college. And there, I was one of the 2 women in the class, and there were about 40 students in the class. So it was a shock. Plus, I couldn't find the room, and I came in late, and I opened the door, and all the seats were already taken. They were those 40 guys. And then, one guy offered me a seat. Oh, just so sleazy. And then I just did like this woman there. I sat in the front row, very straight sitting, my back completely straight and quiet and taking good notes and trying to disappear and not be noticed. So we were 2 women in the class, and the way we coped was by always sitting in the front row together and working together and trying to help each other. And we had no choice, and we were always the best ones in the class. We were always the top 2 students, and then all the professors would say, "Hey, you guys, look at that, those 2 women are beating the 2 of you," as if it was expected that we could not do good. So it was always this context. Then I went to engineering school, and there we were 8 women out of 2,000 students. The climate was rotten, it was macho, it was I lasted one year, then I left, and I decided to go into physics. There we were 2 women out of 10, and again, the 2 of us were sitting together and working together. At the doctorate level, I was one of 8. I have to say that in the master's level, it was different. We were more women, mostly re-entry students, women who had done something else, lots of dancers and musicians, and they came back to physics. And as a physicist at CERN, there are about 13,000 physicists now at CERN. It's the largest particle physics laboratory in the world, and it's located in Geneva, in Switzerland. And when I started, it was about 12% women, and nowadays it's just about 20%. So I did not have it easy. I was the first woman to teach physics in the 2 colleges where I worked, and my colleagues would not work with me, made it very difficult for me. They didn't believe that I wanted to do demos and I wanted to do labs with my students, but they didn't want to be bothered. They said it was a waste of time to do physics labs in college. So they didn't want to do that, but I would take my students to the lab, and I would always go down the corridors with lots of equipment out of carriage to show the students. And then, because my cousin was in another class, I would stop doing the demos in the hallway. And then the students from the other professors were not happy. Everybody was having a great time in my class, and the other ones, they had those boring old thoughts, and they did nothing. So then the guys, essentially, I lost my job. So it was always difficult there. At San Francisco State University, I lost my lecture job for denouncing sexual harassment by Jeff Marcy. You might have heard of him. 30 years later, this guy finally got nabbed. He was one of the world-known astronomers because he was one of the second person, in fact, to find exoplanets, planets outside of the solar system. And he was now at the University of California in Berkeley. And for 30, 40 years, he sexually harassed his students, and he had sex with so many of his PhD students. It was a mess. And he finally got nabbed and lost his job at UC Berkeley. But he was already active at SFSU, and I got a problem with that. Was victim of mobbing at CERN, mostly because I was a lesbian. I can tell you a little bit more about that later. And throughout my career, had less resources and opportunities than my colleagues. So that was not much fun. And I suffered several head injuries. In fact, if you look carefully, I hit the glass ceiling so often. I suffered several head injuries from hitting that goddamn glass ceiling so often. So often I would come back home and ask myself, but what am I doing wrong? You know, I've done better than all the others. They get promotion and I don't. And I could not understand what was happening. And one day I just went like, you stupid. You know, it's the glass ceiling. It was so much easier. It was not me. It was how it was, and it was much easier for me. And it's too bad, because it had started really, really nicely. I was in California, and I was associated with SLAC, where even the physicists are progressive in California. So it was really nice. And I was young, out as a lesbian, I felt invincible. And it was so easy in the Bay Area, around San Francisco and all that. It was wonderful. And I started out with a sexist advisor, but I left him and I changed for an open-minded, progressive female advisor. And that was such a good one. Don't stay with an old heart. Be it a woman or a man. Don't stay with someone who does not support you and will help you. It's not worth it. Just find someone better. And when I was in California, there were lots of other gays and lesbians at SLAC as well, so it was not even an issue. Nobody bothered about that. It was really easy. Here is what I wore for my thesis defense. Now, I had a T-shirt where it said, I can't even think straight. So, and I had this silly hat that my girlfriend had given me with feather and stuff, and fake ocelots. And so I had 4 or 5 professors for the thesis defense, and one of them, his only question was, why are you wearing this hat? So it was pretty easy. Nothing on the form factors of semi-leptonic decays of this stuff. So it was nice. Then I went to Fermilab, which is near Chicago. That was for my thesis work, in fact. And I had a female PhD thesis advisor, a woman who was extremely supportive. She was clear about feminism, and she saw that there were sexism, and she would protect me all the time. In our group, it was all women. So this professor, 3 students, 3 PhD students, and 1 postdoc, and we were all women. And at one point, she hired a guy, and the guy's name was Guy Blaylock, and we called him the token guy, because she took him to have a guy in the group. He was a good person. So in this experiment, E791, small experiment at Fermilab, there were about 70 scientists, 10 women, and we were part of the core group running this experiment, because on an experiment like this in particle physics and other fields as well, you often have a core of people who are based at the experiment and they run the show daily and all that. And you have some professors who are teaching in their universities and they come for meetings 3, 4, 5 times a year, and then when they have time not teaching, they come and they do something. But among the key people, there were lots of women. And there were 2 co-spokespersons for the experiment, but it was really a woman without a title who ran the show. And she was quite wonderful. So there were lots of women in the core group, and our best arm was humor. The guys were often so ridiculous, and they would be sexist, and they would be stupid and all, but we would just laugh at them. And it was so easy, and there is strength in numbers, as the saying goes. And so it was really easy, because we were together, we had a ball there. It was really wonderful. Like, for example, one day, this woman who was running the show, Jean, said, we will have a dress rehearsal for the experiment because the beam was coming and all our equipment. And I have no idea, English is not my first language, dress rehearsal. So I said, what is a dress rehearsal? And she said, you just have to stand there and look pretty. I said, okay, fine. So after lunch, we all came back. I had my mother's wedding dress on, and Dan Ying, she had the dress that her mother had sent from China, hoping that she would get married, and Penny from Australia took our best dress. So we could always make good jokes like this, and it went well. And with Penny Casper here, we were 2 graduate students, and we were in charge of the calorimeter. And this calorimeter was made, it was the electromagnetic calorimeter, it was made to detect leptons and photons that would come through the detector, like electrons and photons. And it was filled with, it was LED panels. The structure was made of LED, and it was filled with scintillating oil. And when a photon or an electron would get through, it would scintillate, so more photons would be produced. These photons would find their ways down to the wave shifter, which was just changing their wavelength. And then it would become in the visible, in a range where the photomultiplier tubes were more sensitive. And then, so here is just the front view, and it was about 1.5 meter deep. And so there were these wave shifters here that would collect all the light coming. And at the end here, we had a photomultiplier tube, and then we could tell when a particle had come through and all that. The problem was that there was a leak somewhere. And there was oil that was leaking on one of those wave shifters, and it ruined the property. The optic fiber works because of the index of refraction, the refraction index, and the oil was matching the refraction index of the plastic used for the wave shifter, and then the light would escape from the wave shifter and didn't work. So we crawled in there under the detector, and it was disgusting, dirty. This had been installed 10 years earlier. There were some animals that were going around, we don't know what, but we found a piece of shit that was about big like my finger, fresh. And we had to crawl under the detector like this, My nose was too big, I had to go on the side like this. And Penny, it was her breast, she had bigger breasts, and her breast would get, so she had to squeeze her breast, get in there. And then we found that piece and the dust, and it was disgusting. And then we looked at it, and we removed that piece of plastic, that strand, this rod of plastic. We saw where the leak was coming. And it was getting late, it was about 12, it was time to go for lunch, and we looked at it and there was a leak, and then we thought, what could we do? Then we had an idea. We went back home, got what we needed, we came back, and then there was a meeting a week or 2 later with all the 70 people from the experiment, the physicists from the experiment, and then we said, yeah, we repaired the calorimeter. People said, what did you do? And we said, so here is the picture of I'm under the detector fixing it. And so they said, what did you do to repair it? And I said, I used some high-tech absorbent material, and I flashed that on the thing. So people It was so amazing. The women were laughing, the guys just went red. All of them red, bright red. It was great. So, and when they dismantled the detector, the head of the experiment asked me, is there anything you'd like to retrieve from them? And it was funny because afterwards, when I was telling the story, all the male physicists would have the same reaction, they would blush. And the female physicists, they all had the same question, which was, how often do we have to change it? So, at Fermilab, I had a great time because we had a group and we supported each other and it was really easy. It's not, our colleagues were no less sexist, I guess, but the context was much better. Then I came to CERN and it was a much more conservative environment. And I lacked, when I arrived, I was a postdoc, and I lacked a supervisor to protect me. The professor who was my boss, was not doing much and didn't care for me, didn't protect me the way my thesis advisor had always looked for me, looked after me and all that. On the Opal experiment where I worked, there were about 400 physicists, maybe 10–12% were women. And as a colleague of mine made me notice that most women were married to a physicist. So those women were kind of protected. Nobody would make a nasty comment because the husband was also in the experiment. So the word would get out and people would get in trouble. But I was the lone lesbian and I was out and all that. I was used to live like that. So I was too different and I stuck out like a sore thumb, like they say in English, that I was an easy target. At CERN, everybody eats together at the cafeteria, Every group leaves at lunchtime and they go and they sit together. We have a wonderful terrace and it's really nice, but I always ate alone. Later on, I was given a very nice opportunity of leading a lab, and that was really nice. I got the lab, the first job was to get the floor clean and waxed, which was done. Then I had to install all the gas lines. That was my first experimental setup and all that. That was in December 2002, and then I had to get storage area and all that, because I was participating on one of the detectors for the LHC, the Large Hadron Collider. This is the Atlas detector, and we were doing one sub-detector, which is called the TRT. It's a tracking device. So the modules are like this. They have straws and some ionizing material inside. So when a charged particle goes through, then you detect something at the end of a wire. So you have 400 little straws with the gas and a wire in the middle. And it's a tracking device. So you can see where charged particles went through the detector. And so then the modules were built in the US, they were shipped to Geneva, and our job was to make the quality assurance, making sure that everything was good. And so in about 2 years, we built a huge lab. We were 2 or 3 people to do that. I had an excellent engineer with me. And so he was organized. You saw my table, my setup was really like a physicist. But here is when you have technicians and engineers on board. So it was a huge thing. We had to test all the wires. So there were hundreds, 9,000 wires that we had to check one by one and all that. So we had to devise things to make it faster, more efficient and all that. And so that's what we did. I headed the lab alone. A guy, was supposed to be doing it with me, but he never came because his wife didn't want to move to Geneva. So I was left alone to do the job. And it was really a job for 2 people, but I was alone. There was a small team of 2 or 3 people there, and we built everything. We tested 104 modules, in total 105,000 wires. We improved the modules' quality way beyond the expectation. People had thought, we will end up with about 5% dead channel. We reduced that to about 1%. So we did much better than all the others who had built the modules. We repaired them and all that. And we met all deadlines. Nobody was meeting that deadline. And so at the end, so if you look again, the module, you see those lozenges? It's like 2 triangles. So when we look at the 104 modules now are installed, and they form a whole detector. So when particles come through, we will see they will hit several wires on the way, and then we get dots, and we can connect the dots, and we can reconstruct where the particles went through the detector. So that's the detector once it was all assembled. So what did I get from all this work? Nothing. I didn't get any promotion. I didn't get even a thank you, I guess. When they were building the detectors in the US in 3 universities, we had weekly meetings, and as long as they were doing the production in the US, they were the weekly meetings, everybody would drop their work, including me who had started receiving modules and fixing the problems. We would all stop our work and we would sit together, about 8, 10 people, and discuss all the problems. Ah, yeah, I saw that last week and we fixed that. So, and everybody would help each other. Once most of the modules were in my hands, then people stopped coming to the meetings. Their job was done and they left me deal with my problems. It was no more their problem, which is not at all the way it's supposed to be in our field. So then all the work that I did was attributed, all the merit was given to a man who came 3 times to my lab and asked me, so what do you do again in this lab? And I would explain to him from bottom to top all the steps that we were doing in the lab to test the modules. And he could not understand it. And he was given all the credit for having done that. And then he became even the group leader of this 100 people who were working together on this. Then there was also mobbing that started against me. And it started by the project leader. So the whole group to do the mechanical assembly of those detectors, the electronics, all that. We were about 70 people. And there was a project leader at the top of it. That man was quite homophobic, and the mobbing started by him, but many of other people joined in. And I found out that it was homophobia because when he first announced that I would be the head of the quality assurance lab with Doug, the guy who never came, he said, oh, this is good, we will have a bisexual team. He meant, we will have a mixed team, a man and a woman. But no, he made this lapsus. Instead of saying a mixed team, he said bisexual. Because all he had in mind was the fact that I was homosexual. So he mixed things. So then people would come to meetings and they would insult me during the meetings. Like this dog walked in one day, scratching his crotch, walking like a big oaf. And then I'm giving my presentation to show what we have done. And then he shouts, bullshit, you've never done anything. And nobody in the audience stopped that. So that kind of attitude, I've never seen something so low. I had a nervous breakdown, went back to my garden, I had made a lot of zucchini bread that summer. And finally, I moved out of this project because there was no way. There was no way. I had no support. There were very few women. Of those 70 people, we were about 4 or 5 women. It was a very macho thing. The project leader was the one heading the mobbing, and all those who were jealous, like Doug, who never did anything, who was supposed to do it and could not because his wife wouldn't come, was jealous that I succeeded. So all those people would insult me at meetings and all. So I left the detector project, and I had to, where I was thriving, I had done so good and all that. I joined an analysis working group, and there was a higher fraction of women. So it was a better atmosphere, People were not acting like oaf, like I described. I did better, but I did not thrive. And mostly, I did not have the support of my university group. I never had a group with postdocs or students working with me that would be a nucleus, and then you go to a larger meeting and you're a group together and you stick with each other, you help each other. That's the way people work. So my own group never bothered to, when they were recruiting new students, my research topic was never offered as a possibility. And one day I had to fight. I said, no, the next postdoc works with me. And I really fought for it, and then I hired someone, and then I did a bit better. But eventually I was recruited by the CERN communication group and to join them. It was almost all women in the group. The head of the group was a man, was really wonderful guy, open-minded and all. And he was really supportive of me. And something happened that I had never had in my career. People were praising my work. I would write blogs for CERN, blogs to explain the research that was going on at CERN and all that. And it became very popular. We had 100,000 followers or something like that. And finally, I got to try. It was really wonderful. The only problem was a temporary job. It was for 1 year. They renewed it twice, but then the director general told me, now we cannot do more than that. He tried to give me a 5-year position, but then CERN had a hiring freeze and he could not open a position for me. So then again, I was lucky. I had just met my current wife, and so I decided, okay, that's it. I'll write a book, and so I came here. But the whole time I had to ask myself, what's wrong with me? You know, why can't I get a promotion? Why are my ideas so rarely acknowledged? I would present something in a meeting and it flew like a rock. And then a few minutes later, one man would repeat the same thing. Oh, yeah. It's called heat-beating. It's so common it has a name, heat-beating. Why is my work attributed to others? Why can't I get people to work with me? Why am I always denied a talk in Atlas? In the 10 years I was with Atlas, I never got an official talk. Never. I gave a lot of talk because people were inviting me as a keynote speaker or whatever. And then they would pay for a thing because my group would never send me anywhere. They would not pay for me to attend conferences or workshops. And I remember at one time there was a graduate student who was sent 3 times as a speaker, and I had no talks myself. What is this? And why do I have always to eat alone at the cafeteria? So it was really schlimm. So then you ask yourself, do I stink? You go and you check yourself. So what is wrong? And then, fortunately, during that period, my partner was a very strong feminist and all that, and it helped me a lot put things in a better context, because that was the slogan for the feminists in the 60s or 70s, the personal is political. And that helped me a lot, not to take it personally, but to see that it's not me, there's something else going on. Of course, things have evolved since 1909. In the last century in physics, now, here you have a very famous Solvay conference in 1909, where the only woman there is Marie Sklodowska-Curie. And she is with all the big names of modern physics, Debye, Planck, Bragg, Dirac, Lorentz, Einstein, Langevin, de Broglie, Born, Bohr, Heisenberg, Pauli, Schrödinger. So all the big people. But there were no women almost at the time. Things have changed. If you go to the summer school, for example, you're likely to see a crowd like this, very diversified group. But at CERN, it's still roughly 80% male and 80% white. So despite diversity, when you look at the students, it looks good. But in fact, if you look here at all the users coming to work at CERN, you see that there are about 13,000. So it's here the member states. Roughly it's Europe and Israel now. And there are associate member states, India and Pakistan, Turkey, Ukraine are now joining CERN. So CERN was the European laboratory for particle physics, but they're opening it to other countries now. And so you can see, for example, from India, there are about 400 people. There are lots of women there. Algeria, 14. From Mexico, 82 physicists. The first Mexican physicists were working with me at Fermilab, so that's really nice. They made a big group. Sweden, 85 people. Germany, it's a large group. 1342 physicists. United Kingdom, about 800. But you see, when you look at the distribution of where the people come at CERN, mostly come from Europe because it was a European lab initially. But now we have people from Asia, and there you have about 20% women, mostly because of India. India has a very large fraction of female physicists. Japan has just about 0. In Europe, it's about 17%, North America 17%. The highest proportion is in Africa. It's really nice. There are lots of women there, and there are very few people from Oceania and South America, but the fractions of women are similar. If you look at the people under the age of 35, we can sort of predict, will it change? Will the proportion of women improve if we look at the younger people who are in the pipeline? But see, Asia is at 24%, Europe is at 23%, 20% for North America. So you see, the numbers are not going to change very much. So in 2014, it was about 17%, and now it's about 19-20%. So we need much more young women. And right now, in particle physics at least, there is a decline. There are not so many young women coming in. So as I said earlier, 80% of all scientists are male and 80% are white. The representation of women, that's one thing that we often talk about. But once the women are there, what kind of a deal do they get? So there was a huge study done by the American Institute of Physics about 7 years ago. 15,000 physicists from all over the world, 130 countries, were asked various questions. For example, men and women were asked, do you get access to professional activities? For example, are you sent to conferences? Are you asked to be an editor for a journal? Are you asked to review a thesis on a thesis committee? All those activities. And women from less developed countries, 50% would say yes. And men, 62%. Now, if you look at the error margin, with 15,000 people, the 1 sigma is 0.5%. Okay? So 12% difference is 24 sigma difference. So it's highly significant. Same type of difference for people from very developed countries. In fact, you'll see there's not much difference between less developed countries and more developed countries. Do you get sufficient resources? Do you have enough staff? Do you have enough money? Do you have enough space, in office space? Women receive less office space. I was impressed, Martina, by your office. It's a nice one. Women at Harvard, there was a study made, and they have less square meters per women than men. Sufficient resources, so the women, it's about 10% less, about 10% less than the men. Career affected by children, so when I become a mother, do I still get interesting projects to lead and stuff like that? No. The women will say yes, but their career is affected by having children, but men not so much. And the same thing for, in this case. In fact, men who are fathers are seen as more reliable because they are really the breadwinners now, and now we can trust them and they will do a good job and all that. They are not going to be bothered when the child needs to go to the pediatrician or the doctors or school. Who does the job? Women twice as much as the domestic task, women twice as much as the men. And who are offered less challenges for parents, so it's women are offered, so a third of the women receive less challenge, but a small fraction of men. So you see that the deal that women get is still not equal as what the women, the men get. There is definitely discrimination in physics. For example, in the number of citations. If someone did a study looking at about 200,000 publications in the last 50 years, published in the 5 best astronomy journals. Things like Nature, like, oh, I'm not good, Science, and I forget the other one, the big ones for astronomy. But, so the top journals where your paper has to be absolutely top-notch. So you know that all the papers published in those journals are of very high caliber. Then the number of citations for men with respect to women, it used to be in the 60s, 70s that men would receive twice as many citations as women. So we're talking at equal quality papers. And today, it's about at the level of 5–10% nowadays. So it's still, and it's often used as a, this is a fair criterion to use to judge men and women. You can look at the number of citations to hire people. No, it's not a fair, objective, neutral criterion. It's biased from the start. Women get less citations. You're all going to leave the room depressed, but no, you'll see that get it. Sexism in how students are evaluated. Yesterday, I know Martina talked about a similar study. There were 127 science professors in 6 American universities who were asked to rate CVs, applications. So it was supposedly a PhD student, a graduate student, who wanted to be the head of the lab for the undergraduate students. And the same CV, the same curriculum vitae was written either with John for the postulant or Jennifer. And they were the same, it was identical, but both men and women professors, so there were women among those 127 professors, rated John to be a 4 out of 5 and Jennifer 3.3. Despite identical resume. Not only that, they offered John $4,000 more per year as a starting salary. I've been there. So gender bias in academia, there is an annotated bibliography, so a list of all sorts of papers that have been written on that. It's a collection of various papers done by these 2 authors. And their conclusion is very simple, is that people are biased. And what is really distressing is that women and men discriminate against women, and women and members of minority groups will also discriminate against their own group. So people of color, people of homosexuals, or whatever, will discriminate against others as well, because the stereotypes are internalized. And we live in a sexist society, so even women have often, sometimes, make sexist comments, or will have sexist bias. So everyone has to fight that. Gender biases come from repeated exposure to stereotypes. You know, how often do you see, you don't see enough women? Now there has been an effort to portray more women in science magazines and books and all that. But it was not the case before, so like at CERN, it was unbelievable. They did this thing with kids in school, and they would go there and they would ask the kids to draw, they would ask the kid, draw me a physicist. But it was in French-speaking places, so physicist is gender. So they would say, with the word that they would use, physicien, they would ask, draw me a male physicist. So all the kids made a male physicist who looked like Einstein. And then they would make a talk and show lots of women physicists, and then the kids would, half and half, they would also draw women. But of course, if you use a word that is sexist from the start. Anyway, so the gender biases are pervasive. We need conscious, structured, institutional efforts to counteract those biases. So when there is a hiring committee, people must be made aware that, be careful, no, you don't go assuming that because she comes from a developing country or he comes from working class background or whatever, that you won't have a bias that this person won't be as good as the others. All decision makers should read these studies, and for example, the number of citations and productivity are not objective criteria, but they are biased. Oops. Yeah. One other thing was also another study, same thing. You send CVs with two names. If you put names like Emily and Greg, will they be more employable than Lakeisha and Jamal? So they found, in fact, that again, when they send exact same resumes, just changing the name of the applicant, so the white names, Greg and Emily, will receive 50% more callbacks for an interview than if you have a name which is Muslim or Indian or different. Okay, so this is why it's so important to make anonymous application. I'll come back to that. And there is also the discrimination based on class. If you look at the number of women from less privileged backgrounds, there are very, very few here women who come from a working class background who are physicists. Most women come from parents who were highly educated. Same thing for men, only 22% were first generations university students. Okay, so there is also discrimination about your social origin. So throughout all this, being hit all the time and hitting my head and all that, there are a few things that I have learned that really made an impact on me and made me smile a bit more. And one of them is this imposter syndrome. You know, if you ask women, do you agree or not with this statement? And if you say, sometimes I'm afraid others will discover how much knowledge or ability I lack. And most women will say, I agree. Most women are afraid that, you're smiling a lot, is this something that you have experienced? You're nodding too. Is this something that you have thought about yourself that you don't dare asking too many questions at the talk or too many questions to your professor because he or she will see how little you understand? So we are afraid, we just think that we're not good enough. We're trying to make it, as we say in Quebec, sliding on our left bun, just trying to... Maybe they won't notice that I'm there. I'm an imposter. In the German, imposter is Schwindler. As I said, Schwindler. So you know this word imposter, so you're trying to pass for something that you are not. And this imposter syndrome hits not only scientists, but all highly successful women. And these are women who can't recognize their own achievements. A friend of mine, she was a particle physicist working with me. Now she is the number 2 at the University in Helsinki, Paola Erola. I was just visiting her, I gave a talk there recently, and she was telling me, she was working and working. Nobody will ever convince me that those kids don't have the same capacities to do. There is no study that has ever proved the superiority of men or white people over another group. So, but those stereotypes need to be addressed within the majority group because people internalize them. That us in Quebec, as I was growing up, I told you I'm French Canadian, and French Canadians, we had less opportunities to go to school, less hospitals, less schools, and the best jobs were all by English-speaking people and all that. And us French Canadian, the motto was, we were born for a small piece of, a small loaf of bread. That we should not have big dreams. We were born for a small loaf of bread. And this is less pervasive now, but with the education it has changed now. And so anyway, I know what it is to come from a underprivileged group, but it can be reversed. How to make Women of Color Thrive. That's the title of a paper that was recently published and by these people here. And so they look at a university in a PhD program with the physics students, and the women of color were just thriving in this group. And what they did was to break the isolation through social events. So the members of majority group and the members of the minority groups can meet together through something. The classic thing is to have a beer and pizza evening. So you have a talk, someone gives a talk, and then people stay and have beer, free beers, free pizza, and then they can just socialize and get to know each other. And then people discover that everybody has the same worries about problem number 6, and that homework set was just a nightmare. Then, you know, yeah, and I have so much problem with this professor. And so everybody can share, and then you realize you're all on the equal footing, and you get to know that, oh no, a black person thinks like me, and a man can realize that women also have intellectual capacities. So it helped fight the stereotypes. One thing that women have often done was to start a women's group, and then you have support from your peers. But what they tried to do was to make the support group would be the group itself, the group where the women of black women were, such that the whole group would become a safe place. So and also it's important that people in a position of authorities will fight microaggressions in those safe spaces. Make sure that the faculty members will dissuade any discriminatory behavior and turn the workplace into a safe place. Like at CERN, when we started the LGBT group for lesbians and gays and transsexual people, we were saying, oh yeah, we want a safe place, but the workplace should be a safe place. So it's a way to do that. Another thing that is important that they were mentioning in this paper was that intelligence is not something that you're born with and you have this big in your brain and that's going to remain like that forever. So, no. Intelligence is something that develops. You learn to become a physicist. Okay? You learn to approach a problem the right way. You learn to do research. You learn to work in collaboration and all that. So intelligence is something that can develop. And you can also fight the stereotype of the lone genius in science. And of course, the worst stereotypes about that is Albert Einstein. You know, this man who came apparently from nowhere and then came out with all those incredible theories. But what is very little known, who among you here has heard about Mileva Maric-Einstein? Bon, I'm in a good crowd here, that's good. That's really nice. So that's my current project. I've been working on this, on getting the story of Mileva Maric-Einstein being better known, and I'm now working on making a movie on this. And this is why I'm taping the thing, because we have to do promo, and so we'll use some of this material here. So I'm working with someone in Hollywood to make a big film, a motion picture, to tell the story of Mileva Maric-Einstein. They have worked together, and he never mentioned it, so they were collaborators. So this is you can read an excellent book by Radmila Milentijevic, a biographer of Mileva Maric, and it's called Mileva Maric-Einstein, Life with Albert Einstein. It's an excellent book. I recommend it to you. And another 15 minutes, Martina? Yes, okay. So recently, about 2 years ago, there was a study made by the American Physics Society on the climate for lesbian, gays, bisexual, and transsexuals in physics. So they produced a report, and their executive summary I put here. So most people, a lot of people reported, LGBT physicists reported having faced an uneven protection and support from legislation and policy. So it's in the US, so of course it changed a lot from one state to the next. But 50% of the respondents said that the US policies were supportive, but that's for lesbians and gays. The trans people say only 40%. Trans people are the ones who are the most discriminated against. 30% say that they are uneven and lacking or discriminatory. And the trans people again say way more than that. The overall climate experienced by LGBT physicists was highly variable. So when people were asked, is the overall climate in your department uncomfortable? And it's not so bad. The gay guys would say about 15% would say, yeah, it's uncomfortable. The lesbians would say, 25% of them would say it's uncomfortable. And the gender non-conforming people, 30%. Trans and transsexual, transgender, non-binary. So, in many physics environment also, people felt that it was better not to say that you were lesbian, that it was better to be closeted, that is, that you don't tell people who you are. Isolation was a common theme for many LGBT physicists, lack of project, and it comes often from having a lack of professional networks. They're trying to start an LGBT network in physics, lack of mentoring or role models. There are not so many well-established physicists who say publicly that they are gays or lesbians or trans. There is a significant fraction of LGBT physicists who have experienced or observed exclusionary behavior. That means that they have seen sexual or verbal harassment, homophobic comments, exclusion from study groups or social activities, expectation of incompetence. A friend of mine at CERN, he was always going around, always at the cafeteria, always knitting like a bad man, just knitting. And he was just flamboyant and all that. But he told me, put on my, okay, I do all this, but when I'm in you can be sure I'm the best nuclear physicist you can find around. Nobody will find a flaw in my science, in my physics. So this guy knew that by being himself and acting like he wanted, he was at risk, so he made sure that he was the best physicist. Just like me and the other woman in the class, we were always the best. You have no choice. In fact, in physics, you won't find any woman who is below average. They're all gone. But you will, 50% of the men in physics are below average. But the women are not. The women are so top physicists. So, having seen that, 20% said that they experienced it, and 40% said having observed it. But for trans people, it was much higher. 49% have experienced it, 60% have observed. So of course, some would say I have observed it because they're not out. People don't know, and then they don't. So LGBT physicists are. So if you're a woman and you're homosexual, you're 3 times more likely to suffer from exclusionary behavior, eating alone, not having people working with you, or not being able to really blend in a working group. And that was really my situation. So 3 times more. So when you have a not double bias, but double. You belong to 2 minority groups. As a woman, as an LGBT person, then you're much more likely. That's the case for black women have really a tough time, but black lesbians have it hard. So it's much worse for people of color. So this is something that I had never seen before. It was really strange. This thing about isolation, I had never read it anywhere. And I was reading this report, preparing for this talk, and that was about a month ago or something like that, and I was reading it, reading the report, and I found myself crying, and just came in waves and waves. It's like all that pain was coming out. It was very strong. I had never seen this thing about isolation, and I didn't know what it was. I said, no, do I stink? And it was I realized all that pain that was still there in me 5 years after leaving CERN. And my girlfriend came later for dinner and all that, and I was still completely shaken up, and it took me days to recover from it. And I had not realized how much pain I had carried. I was still carrying on. So anyway, transgender and gender and non-conforming physicists are the ones who encounter the most hostile environments. And many are at risk of leaving, so a third are considering leaving their workplace or their school. And many reported trouble identifying allies, that other people who would be supportive of you. So that was my case also, when I was attacked in those meetings where people were shouting insults at me, when I was presenting my results on how many wires we had replaced in that module, and people would shout, and nobody defended me. It was so awful, difficult to fight at. So how did I manage? That's the big question. The first thing is that, as a kid, I wanted to know what matter is made of. But now, the thing that, for 20 years, the thing that really, really passionate is finding out what is dark matter. What is this business about dark matter? So my passion for science was never altered. I'm still passionate about science and finding out how it works and all that. So that helped me going. But also, I tried always to fight the isolation by, for example, co-founding the Atlas Women's Group. And we did all sorts of nice things. We had a mailing list so we could contact each other. Atlas is an experiment with 3,000 physicists, and about 20% were women. So it was a way to reach everybody. We had a weekly lunch, and we just reserved a bit of space in the cafeteria, so whoever had time could come. And when there were elections within the structure of the Atlas, we would support women candidates. We raised funds to bring 2 young Iranian women to CERN at the summer school. We made a list of female experts for the CERN summer school, because at the CERN summer school, the guy who was organizing it, he had something like 8% female lecturers there. We told them, what is that? You know, we are 20% of women, and in the summer school you have about 40% women. What is that? Oh, we cannot find good women for talks and stuff. So then we took our mailing list, and then we extended it to all of CERN, and we said, okay, who is an expert in those topics that are covered by the summer school? And then we got a list of 238 names, which we sent to this guy to say, now if you need an expert, look at our list. We organized also hands-on workshops for high school girls, and we did this very nice event, CERN-wide event on March 8, 2010. That's one of the pictures that I proposed to the Director General. I said, let's make a big coup, a big publicity coup, showing that there are lots of women now in physics, and that women take an important role and play an important role and all that. And I said, let's all staff all the control room, the 4 control room for the large experiments at CERN and the accelerator, only with women. So from 7 o'clock in the morning until 11 at night, there were only women. So it was about 100-some women who took place. So that's the group that was running the Large Hadron Collider during the daytime. The funny thing is, it was so easy to find enough women to do it. And it was really a visible thing. And I knew the guy, and if we had done something to claim something, he would have said no. But there it was just to look good, so okay, he said yes. And so he agreed that I could organize that and all. And it was really nice. The same day, Air India did the same thing, but they staffed all their big, long-distance flights only with women crew. Pilots, co-pilots and all that for the big long-distance flight, New Delhi, New York, things like that. So at the International Women's Day in 2010, so here are the pictures taken from the 4 different experiments, Atlas, CMS, LHCb, and ALICE, and also in the main control room for the accelerator. And then a few years later, there was also a group, LGBT group started at CERN in 2010. It was already 15 years after I had arrived at CERN. It took 3 years for CERN to officially recognize us. You know, the tennis table club, that was okay, the canoe club, the music club. But, you know, you have to understand that we have very controversial activities. We had a mailing list. We had weekly lunches. We would sometimes go and look at a movie, advise a certain diversity group, and more recently they organized events for the International Day Against Homophobia and Transphobia. And this is one day we organized a visit at the Atlas detector for the other physicists from other experiments who had not seen it, and so various activities like that, but mostly men, of course. And the other thing that helped me survive, so I had the Atlas Women's Group, so then I had other women with whom I could talk, the LGBT group, but also by holding on to feminist ideas. And then I was able to tell myself that it's not me. And we, just to end, the Director General had asked me to do a thing with young women to try to figure out how could we improve the situation for women. And we came up with a series of resolutions that they never applied, which were, and we divided them in 3 sections. How can we attract more people, not only women, but people from minority groups into physics? And so discuss the origin of discrimination, the point that we discussed earlier, I mentioned earlier. Bring strong physics identity. So this is something that some researchers found, that students who have a strong physics identity are people who can identify to themselves as being a physicist. And it was something that you could foster by discussing the origin of discrimination of sexism or racism. And so then the thing that you can do, you can give opportunities to the students to teach their peers, so they would help each other. And then, of course, the students have to feel that they're good at physics to think about becoming a physicist. If you're not good at it, you won't want to become. So you have to make sure that the student will feel that they're able to do physics by letting them help the ones who are not so good and all that. Then they realize, oh yeah, I can explain to my friends at home. Fight the stereotypes at our level, provide role models for minority group, and provide mentors to all young people. So those were things we thought could help attract more people from minority groups. We also said that we could hire more people to hire more people. Anonymous job applications are really important because of the studies that I mentioned, where a female name is rated lower, or someone from a visible minority. Giving spousal considerations. You often hear, oh, I heard that one, I'm not going to hire this woman, she's just married and she will have kids and all that, and so I hire a young man instead. But if parental duties were shared equally between men and women, that's a bit what happens in Sweden with the rules that men and women can equally take the maternity or parental leaves. It helps. And give equitable parental leave to both men and women. Here is a study that I heard about from Professor Ulrich Pane, president of BAM, here, the Federal Institute of Material Research and Testing here in Berlin. He said that they take every year 120 students in their program for material science. And with normal selection, so you have applicants and you have the names and all that, then naturally 80% male were selected, just selecting the best applicants. Then they decided, okay, we'll go with anonymous applications. They removed the name, no pictures, no nothing. 80% now are female. It's so shocking. And all the professors who were there are sure that they are completely fair, and the biases are so strong. So this is really something that is worth remembering. But CERN absolutely refuses to do that. And to retain more people from minority groups, provide mentors. Mentors are really good. Someone who is not your immediate director, the one who pays your salary, but another person. Could be a man or a woman, but someone who will, his or her job will be to foster you and help you with, guide you on how do you become a physicist, how do you behave like a physicist, like in the text that you have read from Sharon Twerwick. Have broad discussions about minority issues at scientific meetings, like they did in South Africa. what happens in those meetings, they always have a parallel session for women and minorities. And you have a few women and minorities coming. But you won't see a white man coming to these talks. So in South Africa, the Institute of Physics makes those talks as plenary talks. And I was really surprised. The guys didn't leave. Everybody stayed. It was really nice. And everybody agreed with what I was saying and all that. That was quite interesting. All scientific meetings for members of a minority group. I really liked it here in Germany that there is this DPT, the Deutsche Physikerinnen Tagung. I was invited as a speaker there. It was a wonderful experience. Only women of all sorts of a type of physics, and you get to see other women doing it. You have workshops on how to fight stereotypes or whatever. All sorts of help. It was really, really good. For me, it also gave me a big boost. It's also done by the National Society of Black Physicists in the US, and now there are efforts to implement it for LGBTQ physicists also in the US. So, and I think these things really help us feel stronger. So as a summary, I think physics still has to be more welcoming to minorities. There's still a clear difference in how women are treated worldwide from the big studies of 15,000 physicists. Discussing the underrepresentation of minorities really helped. And I survived by fighting not to stay isolated, by having the women's group, having the LGBT group, and also keeping those political ideas. And I think the most important is don't take it personally. That's where you get all that pain and all that suffering. And remember that the personal is political. Okay? And there was nothing wrong with me. And I'm convinced that there is nothing wrong with you either. Okay. Thank you.
So thank you very much for doing so much. I think also quite a moving talk and very inspiring. So I would suggest that we go now into a discussion, or would you need first of all a break?
No, that's okay. We can. I think it's better to have the discussion now.
Yes.
Yeah.
And I think that we will have some questions, remarks, comments, and so. And I think maybe it's better now that we switch camera.
Yeah, you can stop that. Yeah.